Welcome to our latest video on the topic of structural isomers. This video is suitable for AS and A-level students. By the end of this video lesson, you should understand that structural isomers have the same molecular formula but a different structural formula. You should be aware of the three types of structural isomers that occur: chain, positional and series, and be able to classify structural isomers as one of these three types. And finally, you should be able to name and draw structural formulae for all isomers corresponding to a particular molecular formula. So let's start by defining what we mean by the term isomer. Isomers are groups of compounds that have the same molecular formula but a different arrangement of atoms. And the molecular formula simply tells you the number of each type of atom present. So if we take the compound ethanol, which is C2H5OH, there are 2 carbons, 6 hydrogens, and 1 oxygen present in a molecule of ethanol. So ethanol's molecular formula is C2H6O. The molecular formula simply tells you which atoms are present and how many are present in a compound. Now, the two main types of isomers that we will come across are structural isomers and stereoisomers. Now, structural isomers, which we're going to discuss in this video, are isomers that have the same molecular formula but a different structural formula. In other words, they have a different arrangement of atoms. Now, the other main type of isomers that we'll be discussing in later videos are stereoisomers. And stereoisomers have the same molecular formula and the same structural formula. So in other words, they have the same bonds between the same atoms. Their only difference is that they have a different arrangement in space. Now, these isomers include optical isomers and E and Z isomers, and we'll be discussing these in later lessons. In this lesson, we'll focus purely on structural isomers. Now, structural isomers have the same molecular formula but a different structural formula. In other words, the atoms are linked together in different ways. Now, it's really important to understand structural isomers that you understand what is meant by the term structural formula. Now, structural formula shows the sequence in which the atoms are bonded together. And it could be written in full with every bond drawn, like we've done in the first diagram here for 2-methylpropane. Or it can be written by joining groups of atoms in sequence, as we've done with the other 2 representations here. So they're all structural formula, but full structural formula is where you draw every bond out. And structural formula is there to show you the sequence in which atoms are bonded together. So structural isomers have the same molecular formula but a different structural formula. In other words, their atoms are linked together in different ways. Now, there are 3 types of structural isomerism. These are chain, positional, and series. So if we start with chain isomerism, in chain isomerism the isomers have different carbon chains, i.e. the carbon skeletons are different. Now, these compounds will possess the same functional groups and belong to the same homologous series. However, their carbon chains are different. They have different carbon skeletons. So let's look at some examples. So in our first example, we have compounds with a molecular formula C4H10. Now, if you have a molecular formula of C4H10, there are 2 possible structures. There are 2 possible isomers. The first is butane, where you have a straight chain of 4 carbon atoms and 10 hydrogens. Now, the other compound that has C4H10 as its molecular formula is 2-methylpropane. Now, 2-methylpropane has only 3 carbons in its longest chain, and a CH3 group, a subchain, is attached to carbon 2. And therefore, that's why it's called 2-methylpropane, because the longest chain has 3 carbons in it, and there's a CH3 group attached to the second carbon. Now, a CH3 group is called a methyl group, and that's why it's called 2-methylpropane. Now, 2-methylpropane and butane have the same molecular formula, C4H10, but a different arrangement of atoms. That's why they're structural isomers of each other. And they're classed as chain isomers because they have different carbon chains. Butane has 4 carbons in its longest chain. 2-methylpropane has 3 and a side chain, a CH3 group attached to the second carbon. They're therefore chain isomers because they have different carbon chains. So here's another example of chain isomers. These 2 compounds drawn for you on this slide have the same molecular formula, C5H10O. Now, these compounds are chain isomers because they have the same molecular formula but have different arrangement of atoms, different structural formula, with different chain lengths. The first compound has 4 carbons in its longest chain, and a CH3 group is a subchain. The compound on the right has 5 carbons in its longest chain. There are no side chains. The CH3 group is not attached as a side chain here. Now notice that both compounds have the same functional groups. They have an OH group, an alcohol functional group, and a carbon-carbon double bond, an alkene functional group, and they therefore belong to the same family, the same homologous series. It's just their chain lengths that are different. Now this is why they're classed as chain isomers. And chain isomers are the first type of structural isomers. And there are 2 more that we're going to cover in this lesson. These are positional and series isomers. So now let's look at the second type of structural isomerism, and this is called positional isomerism. Now, positional isomers are where you have a functional group in different positions on the same carbon chain or skeleton. So if you have chloropropane, the chlorine could be on carbon 1, and then it would be called 1-chloropropane, or it could be on the middle carbon, carbon 2, and then it's called 2-chloropropane. Now the functional group is on a different position in these 2 compounds, and therefore, because I've moved the functional group to a different position, it's an example of positional isomerism. So now let's look at a second example. So in our second example, we have butan-1-ol and butan-2-ol. Both have the same molecular formula, C4H10O. However, they have different arrangements of atoms. That's why they're classed as structural isomers. And the reason they're classed as positional isomers is their functional group is in a different position on the same carbon skeleton or carbon chain. So in butan-1-ol, the carbon chain is 4 carbons long, and the OH group is on the first carbon. That's why it's called butan-1-ol. The OH group is the functional group. In butan-2-ol, the OH group is on the second carbon. So therefore, that's why it's called butan-2-ol. Both have the same length of carbon chain, and all we've done is move the functional group to a different position on this carbon chain. That's why they're classed as positional isomers. Now the final type of isomerism you will encounter is called series or functional group isomerism. Now these isomers have the same molecular formula but different functional groups, and therefore they belong to different families or homologous series. So let's look at some examples of series functional group isomerism. So if we have the molecular formula C3H6O, it's possible to have structural isomers that exist that are members of different families or different homologous series. So we could have propanal, which is a member of the aldehyde family, and that would be CH3, CH2, C double bond O, H, and that's an aldehyde. Or we could have propanone, which is CH3, C double bond O, CH3, and that's a member of the ketone family. They're members of different families. They're members of different homologous series. However, they have the same molecular formula, C3H6O. And that's why they're classed as series isomers, because they're members of different homologous series. Now, a second example of series isomerism is shown on this slide, and that exists between alcohols and ethers. So if we have a molecular formula C4H10O, one possible structure for that molecular formula would be butanol, and that would be an alcohol. That would be CH3 bonded to CH2, CH2, CH2 bonded to an OH. Now this compound would have a series isomer, and that would be an ether. And an ether has an alkyl chain bonded to an oxygen, bonded to another alkyl chain. And even though we don't study ethers at A level, we do come across them in this topic because it's an example of a series isomer of an alcohol. And this has a structure CH3, CH2O, CH2, CH3. And both the ether and the alcohol have the same molecular formula, different structures, and they're members of different families. They're members of different homologous series. And that's why they're classed as series isomers. So we're now going to test your understanding of this topic with some practice questions. So here's our first practice question. We want you to look at the two pictures and the structural formula underneath the pictures, and we want you to name the type of structural isomerism that is shown below. And for part B, we want you to name these two compounds and give their molecular formula. Pause the video, have a go at the question, and then we'll go through the answers. So now let's go for the answers to question 1. So question 1A is asking what type of structural isomerism is shown below. Well, if we look at the pictures and we look at the structural formula, we can see that the OH group, the functional group, is moved to a different position when you look at the first picture and then we look at the second picture. So that means that the type of isomerism is positional. Positional isomers involve the functional group being on different positions of the carbon chain. Now, the next part of the question is asking you to name the two compounds and give their molecular formula. So our first compound is called pentanol because we have an alcohol, we have 5 carbons in the longest chain, and the OH group is on carbon 1. So that's why it's called pentanol. And our second compound has 5 carbons in the longest chain, and the OH group is on carbon 2. So it's called pentanol. They are positional isomers of each other, and both have the same molecular formula, that is 5 carbons, 12 hydrogens and an oxygen, so its molecular formula is C5H12O. So for this question, there's 1 mark for getting the type of isomerism correct, 1 mark for saying positional isomerism. There's 1 mark for getting the molecular formula correct, C5H12O, and 1 mark each for naming the compounds correctly. So here's our second practice question. So once again, we're asking you for the type of structural isomerism that is shown below. we're asking you to name the two compounds and give their molecular formula. So pause the video, have a go at the question, and then we'll go through the answers. So here's the answers to question 2. So the type of structural isomerism that is shown below is chain isomerism. And this is because the two compounds that we have below are hexane and 2-methylpentane. Notice that they have different carbon skeletons, different carbon chains. The first compound has 6 carbons in the longest chain, and the second compound has 5 carbons in the longest chain, and a CH3 group, a methyl group, on the second carbon of this chain. Because they have different carbon chains or carbon skeletons, we are classing them as chain isomers. Now, the molecular formula for both compounds is C6H14. So if you had the correct type of isomerism, you get 1 mark. If you had the correct molecular formula, you get 1 mark. And there's 1 mark each for naming the isomers correctly. So here's question 3. Once again, we want you to name the type of structural isomerism that is shown below. Then we want you to name the two compounds and give their molecular formula. Pause the video, have a go at the question, and then we'll go through the answers. So now let's go for the answers to question 3. Now the type of structural isomerism that's shown below is series or functional group isomerism, and there's 1 mark for that. And the reason it's series isomerism is because the two compounds that are shown below are members of different families. They're members of different homologous series. They have different functional groups. The first compound is classed as an aldehyde because it's got a C double bond O and a H, and it's CH3, CH2, 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 C double bond O and a H, and that's called pentanal because it's 5 carbons and it's an aldehyde. The second compound also has 5 carbons, but it's got a different functional group. It's CH3, CH2, CH2, C double bond O, CH3. Now that's a member of the ketone family. It's got a ketone functional group. So that's why they're series isomers. One's an aldehyde, one's a ketone. They're members of different homologous series. However, they do have the same molecular formula. That is C5H10O. So now have a go at our 4th practice question. Once again, we want you to name the type of structural isomerism that is shown below, and then we want you to name the two compounds and give their molecular formula. Pause the video, have a go at the question, and then we'll go for the answers. So for question 4, the type of structural isomerism that is shown below is positional isomerism. And this is because the functional group, the chlorine atom here, is moved to a different position. So if we look at the first compound, we have 5 carbons in the chain and the chlorine is on carbon 2. So it's called 2-chloropentane. And the next compound, the chlorine is on carbon 3. So it's called 3-chloropentane. All we've done is move the functional group to a different position on the carbon chain. Now the molecular formula is C5H11Cl. There's 1 mark for the type of isomerism, 1 mark for the molecular formula, and 1 mark each if you name the isomers correct. So here's question 5. Now for question 5, we want you to draw all the structural isomers for C5H12. And there's 3 marks for this question. Pause the video, have a go at it, and then we'll go for the answers. So now let's go for the answers. Now our molecular formula is C5H12, and because the number of hydrogens is double and add 2 compared to the number of carbons, it has to be an alkane. So the obvious thing to do first is to draw the straight chain alkane that's got 5 carbons in, and that would be pentane. And pentane would have 5 carbons and 12 hydrogens. Now, the second compound I'm going to draw has to be a chain isomer. It can't be positional because I don't have a functional group in an alkane, so I can't move it to a different position. And it can't be series because I can't have an isomer that's a member of a different homologous series because it's got a different functional group, because there are no functional groups in an alkane. So all I can do is cut the chain length down. So my longest chain here is 4 carbons. That's 4 in the longest chain. So therefore I have a CH3 group that I can put as a subchain. So if I put this on carbon 2, the compound is named 2-methylbutane. Now it's always useful to name the isomers that you draw because every unique isomer will have a unique name. If you end up having the same name, you've drawn the same isomer twice. So in my next example, I can't put the CH3 group on a 4 carbon chain anywhere else than on the second carbon. Otherwise I'm just drawing the same compounds. I'm either drawing pentane or 2-methylbutane again. So all I can do really is cut the chain down to 3, and then I have 2 CH3 groups to put in. So if I put them on the middle carbon, that would be called 2,2-dimethyl propane, because a alkane with 3 carbons in is propane. Now all 3 isomers have the same molecular formula, that is C5H12. They're chain isomers of each other because the carbon chain is different for each of them. So here's our final question. We want you to draw the 5 structural isomers for C6H14. Pause the video, have a go at the question, and then we'll go for the answers. So once again, the clue here is the fact that the molecular formula tells me that the number of hydrogens is double the number of carbons and add 2. So for example, 6 carbons, 12 hydrogens, add 2, 14 hydrogens. That tells me it's an alkane. So the first alkane I should draw is the most obvious one, the straight chain alkane with 6 carbons in. And that would be hexane, C6H14. So I've drawn that one first. Now, the next thing I need to do is I can't move a functional group to a different position because I don't have a functional group. So I can't have a positional isomer. I can't have a series isomer because there are no functional groups in an alkane. All I can do is cut the longest chain down to 5 carbons. And therefore, when I do this, I have a CH3 group to put in, and I'm going to put it on the second carbon. Now that compound would be called 2-methylpentane because the longest chain is 5 carbons and the CH3 group, the methyl group, is on carbon 2. So it would be 2-methylpentane. And that would be my second isomer that has a molecular formula of C6H14. Now I'm going to draw another isomer, and once again I'm going to draw 5 in the longest chain, but this time I'm going to put the CH3 group on carbon 3. So if I do this, my compound is called 3-methylpentane. And there is no other position on that carbon chain where I could put a CH3 group. Otherwise I'm drawing exactly the same isomers. I'd be drawing 2-methylpentane again if I put it anywhere else. So that is 3-methylpentane. So I now got 3 of my 5 isomers. Now there are no other isomers with 5 carbons in the longest chain. So therefore, I have to cut the chain down to 4 carbons. So I'm going to rub these out and I'm going to draw isomers now with 4 carbons in the longest chain. So if I draw 4 carbons now in the longest chain, I have 2 CH3 groups to put as subchains. So if I put the first CH3 group on carbon 2 and the second CH3 group on carbon 2, the compound I end up will be named 2,2-dimethyl butane. And that is another isomer with a molecular formula C6H14. Now, there is only one isomer left, and this isomer will also have 4 carbons in the longest chain, but I have to put the CH3 groups now in different positions. So I'm going to put one CH3 on the second one, and I'm going to put another CH3 on the third carbon. And if I do that, my compound will be called 2,3-dimethyl butane. And remember, di is because we have 2 methyl groups. So it will be called 2,3-dimethyl butane, and all 5 compounds are chain isomers of each other. They have the same molecular formula, but we have different carbon chains in each of them. The carbon chains, the carbon skeletons are different. So that concludes our video lesson. So after watching this video, you should understand that structural isomers have the same molecular formula but a different structural formula. You should also be aware of the 3 types of structural isomers that occur: chain, positional and series, and be able to classify structural isomers as one of these 3 types. And finally, you should be able to name and draw structural formulae for all isomers corresponding to a particular molecular formula. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, @RadaChemistry.